All right, and you have found a quick review, and this is solving systems by elimination. Some also call this the addition method. Okay, so what do you want to do? You want to add the two equations up and get one of the variables to add out. So you'll need the coefficients to be equal and opposite. For example, if we added the x's right now, we'd get 5x and they would not add out. If we added the y's right now, we would get negative 7y and they would not add out. So we're going to have to manipulate the equations to get them to add out. So I have to choose, do I want to try to eliminate the x's or do I want to try to eliminate the y's? I'm going to go for the x's. If I multiply this top equation by 3, then I'll have a positive 6x. If I multiply the blue equation by negative 2, I'll have a negative 6x and they will add out. So just for clarity's sake, let me rewrite the equation. So now I have 6x plus 6y, and be careful here, a 12 on the right, you have to multiply both sides by that 3. And that's a common mistake. In the second one, we get negative 6x, good, that's what I wanted, equal and opposite, plus 18y, and again, be careful, minus 36. All right, the next step is to add these two equations together. All right, I'm going to do that in green. My x's add out. I get 24y equals negative 24, handy. Let's divide by 24, and of course y equals negative 1. Okay, great. Now in this methodology, we have to still find x, and we're going to use substitution to finish, and you have to determine, okay, do I want to find x by subbing this into the black equation, or do I want to find x by subbing it into the blue? It's your choice. It doesn't really matter. Sometimes one is easier. I'm going to use the black equation. So get 2x plus 2 times my y equals 4, and I'm subbing in this negative 1, right? Okay. So we end up with 2x minus 2 equals 4. Add a negative 2 to both sides. 2x equals 6 and x equals 3, right? And we have just found our point of intersection. It's the point 3, negative 1. We know this is a consistent and independent system because we found a point of intersection. Now, what if you're doing the substitution method or the elimination method, an algebraic method, and what happens if your variables disappear? Either by substitution they add out or by the addition method they add out. So for example, let's suppose I decided I wanted to eliminate the x's. Okay, then I can multiply this top equation by negative 3. My new black equation I'll write down here. It's going to be a negative 3x minus 3y, and again be careful, on the right hand side minus 3. Now when I go to add these up, I get 0 there and 0 there. And I end up with, guess what? 0. Now, what you have to do when your variables add out, is you have to read the result. Okay, you have to read the result. So the variables add out, what do? You read the result. And in this situation, what's left is true. Now, usually when you're doing the elimination method, it'll be 0 equals 0. But the substitution method, you may have like 2 equals 2, negative 7 equals negative 7, 11 equals 11. Whatever's left is true. If that is the case, then these must be the same line, right? The same line. What is the solution when they're the same line? The equation of one of the lines. And I'll use the x plus y equals 1. That's a reduced form. That's my solution, and it would be consistent and dependent, right? They're the same line. Well, what if you did the exact same thing and you ended up with like 0 equals 2? And that could have easily happened if this were a 5, right? Then we would have had 0 equals 2, which would be false, and we would say then no solution, right? This is an inconsistent system. So the elimination method. I covered a couple things here. The idea of getting one of the variables to add out so that you can then solve for the other variable. What happens if your variables disappear? Well, you got to read what's left. If what's left is true, it's consistent and dependent, the solution is the line. If what's left is false, it's inconsistent, there is no solution. Hey, that's it.